Hello everyone, welcome to my channel. In this video, I'll explain you two more problems on finding equivalent resistance. Problem number 1. Find the total resistance between points 1 and 2 shown in figure. While finding equivalent resistance, we always start from extreme end. From this end we have to start. And from the figure, notice that 20 ohm and 40 ohm resistances are in parallel. We can write equivalent resistance for these two resistors as 20 into 40 by 20 plus 40 equal to 800 divided by 60, that is 13.33 ohm. Next, you can see that 50 ohm and this short circuit are parallel. Short circuited means R equal to 0 ohms. So R equivalent equal to 0 into 50 by 0 plus 50, which is equal to 0 ohm. Now let us draw the circuit. This is 13.33 ohm. This is 30 ohm. This is 10 ohm. 70 ohm. And we have one more resistor, 60 ohm. This is 1. This is 2. This is node point 3. This is 4. Okay. Now notice that 70 ohm and 10 ohm are parallel to each other. Okay. So we can write R equivalent for both of this is 10 into 70 by 10 plus 70, that equal to 700 by 80, which is equal to 8.75 ohm. Let me redraw the circuit. And this is 8.75 ohm. Okay. Now notice 60 ohm and 8.75 ohm are parallel to each other. We can redraw the circuit like 1, 2, and this is 30 ohm, and this is 13.33 ohm, and this will be 60 into 8.75 divided by 60 plus 8.75 equal to 7.64 ohm. Okay. From the circuit, we can identify 30 ohm and 7.64 ohm are in series, we can write it like when two resistors are in series, equivalent resistance equal to 30 plus 7.64, which is equal to 37.64 ohms. Let me draw the final circuit. This is 37.64 ohms and this is 13.3 ohm. Equivalent resistance or total resistance across terminals 1, 2 is given by 37.64 into 13.3 divided by 37.64 plus 13.3, which is equal to 9.84 ohms. This is the answer. Now let us discuss second problem. Determine the equivalent resistance of the given circuit. This is the circuit given to us. First, let us identify the nodes. This node is already specified as A and this node is already specified as B. And we can specify this node as C and this node as D. Okay. And for simplicity's sake, I just want to name the resistors. Let this be R1, let this be R2, let this be R3, let this be R4, R5, R6, R7, R8 and R9. Now notice that here R2 and R3 resistors are in series. We can write equivalent circuit equal to 2 plus 2, that equal to 4 ohms. And also identify here R4 and R5 resistances are in series. We can write R equivalent equal to 2 plus 1, that equal to 3 ohm. I will redraw the figure. Before that, I just want to rename this as R10 and this as R11. Now I'll redraw the figure. This is A, B and 2 ohms R1, 1 ohm R6, 2 ohm R7. This is 4 ohm R9. This is 2 ohms R8. Here we have R10. This is R10, 4 ohms. This is R11, 3 ohm. This is how the circuit have been simplified. Now let us see which elements are still in parallel and series connection. This is node C and this is node D, and this is node A, and this is node B. You can see here between A and C, these two resistors are in parallel. That is R9 and R10 are in parallel. So R equivalent equal to R9 parallel to R10, that equal to 4 parallel to 4. 4 into 4 by 4 plus 4, 16 by 8, that equal to 2 ohm. I want to name this as R12. Next one I can see here at between node and C, R8 and R11 are in parallel. I can write R equivalent equal to R8 parallel to R11, that equal to 2 into 3 divided by 2 plus 3, that equal to 6 by 5, which is equal to 1.2 ohm. I would like to redraw the figure now. A, B. This is 2 ohms, R1, 1 ohm, R6, 2 ohm, R7. This is R12, 2 ohm, and let this be R13, and here R13, 1.2 ohm. Okay. Now we can notice that R12 and R13 are in series. No current division takes place. We can say these two are in series. So R equivalent for this is R12 plus R13. I would like to name this as R14. 2 plus 1.2, that equal to 3.2 ohms. Again redraw the figure. A, B. 2 ohm R1, 1 ohm R6, 2 ohm R7, and this is 3.2 ohm R14. Okay. Now from the figure we can see these two are in parallel. Current division takes place like this. So we can say these two are in parallel. We can write R equivalent equal to 3.2 into 2 divided by 3.2 plus 2, that equal to 1.23 ohms. I will name this as R15. I'll redraw the circuit. AB, and this is 2 ohm, which is R1. This is 1 ohm, R6, and this is 1.23 ohm, R15. Okay, you can see current gets divided like this, and from the figure we can say R15 and R6 are in series, which is in parallel with R1. So we can write total resistance or equivalent resistance across AB equal to R1 parallel to R6 plus R15. R1 is 2 ohm parallel to 1 plus 1.23, that equal to, we can write 2 parallel to 2.23, which is equal to 2 into 2.23 by 2 plus 2.23, which equal to 1.65 ohm. Therefore, RAB equal to 1.65 ohms is the final answer. That's all for this video. Thank you.